The topic which we are going to see is the moment of inertia. Moment of inertia of an body about an axis is defined as summation of product of mass and square of perpendicular distance. In general, if we want to say, the moment of inertia is denoted by a symbol I. I is equal to mr square. It is the general formula for moment of inertia. I is equal to mr square. That is product of mass m and the square of perpendicular distance r square. That is mr square. The unit of a moment of inertia is kilogram meter square. We all know that according to the Newton's first law, if the body was at rest, it will remain at rest, and while the body in uniform motion along a straight line will continuously, or unless it will be moving in a straight line continuously unless an external force disturbs. See, for example, if a pendulum, we are seeing a torsional pendulum, the torsional pendulum is rotating about an axis. It is rotating in a same speed unless the force is exerted to it. That is, the angle rotated is the theta. That is, the angle will not vary with respect to any part. If we take this as a reference point, it is go to the plus theta m and minus theta m. This is the what? Inertia. This we are calling it as an inertia. So the property due to which a body does not change its state of rest or a motion is called inertia. So the angular inertia or moment of inertia, it does not depend on the mass, but also it does not only depend on a mass, it also depends upon a distance of a particle from the axis of rotation. If we have a body and we are rotating the body in an axis, means what is the distance between the particle and the axis of rotation? That is, it depends upon a mass of the particle, and also it depends upon a distance of the particle from the axis of rotation. So here we considered a rigid body B, and this rigid body consists of number of particles. All these particles are located at a different distance from the axis of rotation x dash. That is, it was at a distance of r1. First particle, this is particle 1. It has a mass m1. It is at the distance of r1 from x dash. And this is the particle 2. The mass of the particle is m2. It is at the distance of r2 from x dash. And like that, we have several particles. So the moment of inertia of the first particle will be what? I1. I1 is equal to m1 r square, r1 square. Moment of inertia of the particle 2 is m2 r2 square. Therefore, we can get moment of inertia of the entire rigid body by summing all this moment of inertia of an individual particle, of all the particle. That is, I is equal to m1 r1 square plus m2 r2 square plus m2 or m3 r3 square, etc. up to mi ri square. Or in general, it can be written as I is equal to summation of I mi ri square. So this equation 1 represents the moment of inertia of a rigid body. So now we are going to see about theorems of this moment of inertia. We have two important theorem. That is, we have seen that moment of inertia not only depends upon a rotation of axis, it also, we have seen that moment of inertia not only depends upon a mass, but it depends upon a rotation, distance between a particle and rotation of axis, rotational axis. Here we can say that moment of inertia not only depends upon rotation of axis, here also depends upon the orientation of the body with respect to an axis, which is different for different axis of a same body. If the body is oriented in a different axis, then the moment of inertia also will get varied. So based on the orientation of the body with respect to an axis, moment of inertia we are divided into two theorems. One, it is parallel axis theorem, and another one, it is perpendicular axis theorem. So first we can see about what is a parallel axis theorem. The statement of this theorem, that is, we have two axes here. That is, the one, it is with respect to x dash. Another one, it is the axis which passes through the center of mass. There are two axes. So moment of inertia with respect to any axis is equal to sum of moment of inertia with respect to a parallel axis passing through the center of mass. That is, the axis of any axis is moment of inertia with respect to any axis is equal to moment of inertia with respect to parallel axis which is passing through the center of mass and product of mass and square of perpendicular distance between a parallel axis. This is the statement of parallel axis theorem. So now we can prove that what is the parallel axis theorem. Here we can consider a body. The body's mass is m, that is the whole entire body, and then which has a center of mass. That center of mass acts at the point G. And here we have two axes. One it is a dash and another one it is x dash. X dash passes through the center of mass. A dash is parallel to x dash. So let the distance between a dash and x dash, that is two axes, is equal to x. And then let us consider there are particle contains n number of particle. That n number of particle will have different masses, and it will be at the distance of different distance from x dash. So let mi be the mass of one such particle. We are considering one particle. Mass of that particle is mi. It is at the distance of ri from x dash. And then, so what will be the moment of inertia of that particle alone? That is a single particle, means we are taking it as dxx dash. Dixx dash, which is equal to mi ri square. So the moment of inertia of the entire body, if we have to consider, we have to take a summation of the above equation. So summation of dixx dash is equal to summation of mi ri square. So summation of dixx dash, now it can be written as ixx dash. So Ixx dash is equal to summation of mi ri square. What is the moment of inertia of the particle, of this particle mi with respect to the axis a dash? So the particle is at a distance of mi plus x from the, with respect to a dash. So what will be the moment of inertia? I is equal to a dash. So which is equal to summation of mi. Instead of ri, what we have to substitute? Ri plus x the whole square. What is ri? A plus b the whole square. We all know that a square plus 2ab plus b square. Similarly, this is a square plus 2ab plus b square. So a dash is equal to summation mi ri square plus summation 2 mi ri x plus summation mi x square. This is the thing. Then, when we substitute this above equation in a previous thing, we make it that summation I is equal to a dash is equal to ixx dash plus 2x summation mi ri plus mx square. We all know that if the body is a rigid body and then mi ri square will be equal to 0. The meaning is it has equal number of positive value and equal number of negative value. It will cancel out each other. So the momentum will be equal to 0. So summation mi ri is equal to 0. So when it becomes 0, this term fully will become 0. So a dash is equal to ixx dash plus mx square. This is the this equation represents the parallel axis theorem with respect to the statement. When we see that is moment of inertia of any axis which is parallel to the moment of inertia of an axis which is passing through the center of mass is equal to what? Moment of inertia of an axis which is passing through the center of mass plus product of mass and perpendicular distance between the two axes, that is mx square. This is called parallel axis theorem. So what is perpendicular axis theorem? Here it states that moment of inertia of a thin plane body, here we have three axes, x, y, z. All these three axes will be are mutually perpendicular to each other. When we consider each one, all these things will be mutually perpendicular to each other. So the sum of moment of inertia of the thin plane with respect to, that is moment of inertia of a thin plane with respect to an axis perpendicular to a thin plane is equal to sum of moment of inertia of a thin plane with respect to any axis lying on that surface. That is I dash is equal to ix plus iy. That is the thing. So let us consider a thin plane body of mass m and the three mutually perpendicular axes xx dash, y dash, z dash passes through the point O. All these are passing through the center of mass O. And here y dash and z dash lies on the surface of the plane, and xx dash is in a vertical direction, that is perpendicular to all these things. So the mass of the particle of one particle in it is taken as mi. It is at a distance of ri from O. What is the moment of inertia? moment of inertia of the thin plane with respect to xx dash is di xx dash, which is equal to mi ri square. So the moment of inertia of the entire body na di na, when you take a summation, it becomes I xx dash, which is equal to summation of I mi ri square. So in the figure, we can note that ri is equal to y square plus z square. When we substitute this value, we may get I xx dash is equal to summation mi yi square plus summation mi zi square. This is the perpendicular axis theorem. That is, moment of inertia of any axis passing through the center of mass is equal to moment of inertia of other two axes which are perpendicular to that of xx dash. This is the statement.